Thank you very much for this kind introduction. So the next 10 to 12 minutes, I want to give you a short insight into AI-ready imaging modules for biomedical and life science applications. A few words about Opto. Opto is now more than 40 years old. It's 100% private owned, and we have 2 locations in Munich and in France. We are about 50 members around the world in China and US. And we manufacture embedded optical solutions, imaging solutions, and as well as more and more software solutions for that. We as Opto understand us as solution providers in hard and software. That means we produce and develop specific hardware components for very unique problems to solve these problems, and more from the side of the software side. That means we have a hardware module that you takes images, and the most of the job is done in the software. And with this we define 4 main business units. The life science and medical unit is what I'm responsible for. Then the test and measurement, automation, robotics, and the semicon business unit. All this working together, so we build devices that are connected to each of these business units so that we can produce very specific, customer-specific, tailored solutions. What is our market position in between the 2 or 3 big key players on the market? We as Opto are mainly focused on the machine integration. So that means we have small imaging modules that are, can easily integrate it into existing machines or new machines with a moderate price in between from 3 to 50, 20K, and an open software architecture. That means you can easily integrate your own software in our software, or we can integrate or our so-called plugins to solve your application. Since 2 or 3 years, we have standard products available. That means we have our imaging modules. It's also you can see in the exhibition the next door. And this, you see, they are very compact, very stable, no moving parts inside. You have only 1 wire for the connections, and all the job is done by the software. So this is the main overview about our architecture. That means we have our own high-end optical design for these imaging modules. We use only standard components, standard interfaces, standard camera, board-level cameras. We use very standard LEDs. And with this, in combination with electronics and limited form factors of these devices, we can do these jobs in the software way. And we have with this a lot of options, more than 100 options to build such imaging modules with a specific configuration to reduce to your needs. That means we have these imaging modules, and we have 1 specific imaging module for 1 specific job. That means you want to inspect a cylinder or surface, or you want to analyze some cells, whatever. You have a specific tailored module, and all the magic comes from the software. So that means you have a plugin tailored to your needs to solve this problem. We have different form factors that we offer with different functions, with transmitted light, indicated light, coax, fluorescence, 3D. Fluorescence is also possible. With fast sensors, with high resolution, lower resolution. And now I want to show you what's the difference between a traditional one and this imaging modules. You have the traditional one is you have a camera, you have with a connection, you have a tube, with a tube lens, you have this microscope objective and a ring light, and also maybe an indicated light, and you have 3 wires to control it. Without software, without calibration, sometimes with moving parts, we had sometimes difficult. With the imaging module, you have only 1 wire at the end. It's pre-calibrated from us. We have only internal light. That means we have two different light options here with a coax illumination and a ring light illumination. You have a free software platform for that, and you don't have you have only one wire for that. This OptoViewer is free of charge. You can do measurements with that. You can implement your own projects if you want. It's an open software integration, so that means you have APIs for Python or C++, whatever you want. You can also integrate libraries for that. So, and we plan in the future a new generation of imaging modules with 2 magnifications at the same time. So maybe 10x and 20x and 5x at the same time, or more fluorescence channels. It's also possible, and this is what you can see here. So at the same time, we have 2 magnifications, a 20x and a 5x, with a bigger field of view and a smaller field of view, without moving parts. So that means it's very stable over a long time, perfect for the integration into machines. The benefits in comparison to a lab, so I call it a lab microscope. It's really easy to integrate. You have it only from one supplier. All the complete system comes from one supplier, from us. It's customizable. You can't manipulate anything because the lenses, the illumination, it's all fixed on fixed positions. There's perfect for AI. So you have reproducible images over a long time to see what's the parameters at your measurements. And now I want to come a little bit more into my business field, or what I'm responsible for. I'm for the biological and life science market responsible. That means I'm looking for new applications for blood analysis, for microfluidics, also urine tissue analyzing with such modules. That means I want to show now 3 short introductions into applications. It means one is the confluence measurement. The cells often growing on a surface, on a plastic or glass surface, and when the cells have good conditions, they're growing over time, and when they have bad conditions, maybe some poisoning things there, they don't increase, they more decrease, or they are dead at the end. And with an AI processing, you can analyze them, you can measure the shape, you can measure the coverage, it's called confluence, in percentage, and that's important for pharmaceutical development of drugs, and in many scientific questions you need, or you have such cell factories and also the cell growing to detect. So when you think about a time lab or an incubation inside an incubator over 2, 3, or 4 days, you have to track it over the time, how the cells are, they're growing, they're not growing, how much, and also the morphology is sometimes changing slightly over the time, and that's all hints about the conditions of the cells. And with this imaging modules, you can reproducible imaging integrated in such an incubator and can image over a long time. And this is a practical example how the software can work for this imaging module. Another application example is the droplet detection and counting. Here you see a small application example of an imaging module compared with in combination with a pressure-based pump and some liquids here. Inside an integrated is a microfluidic chip device from the IPHD next to here. And with this, we can image, or this is the result, or the images that we come out from the imaging module. With this, we can measure the droplets over time. We have a nozzle that producing droplets, and we can, using a plug-in here that you see, with a general parameters, we can do this, turn this on and off, very, very easy. We can, with a plug-and-play solution, we can do the parameters, and we can also show the results if we want here. So every droplet has an ID, it's tracked over the complete channel, And yeah, we can combine different plugins for that and solve such a solution. Another application example, it's the newest one, is the urine sediment classification. We have such an imaging module, and we take some images of urine samples with many different components inside. You see an overview of how many different objects and components can be inside such a sample, and how many percentage of it is an indicator of an DC, or also what's wrong in your body. Sometimes it comes from different organs, or is it from it can be a lot of different things happen. And we plan at the Vision Show in the first week of October and live demo together with Basler for an AI-based solution for the automated urine analysis. So that means we trained a network with the different components inside, and at the end we get a live image or a live classification of the different parts inside the urine and a percentage, and at the end maybe a diagnosis of this. But it will be in the future. If you're at the Vision Show in 4 weeks, you can come around with your sample and we will see. Okay, with this I want to thank you very much for